Yeah. So, very important to know, one is what is the normal finding, then what are the artifacts, and then third, what are the abnormalities which look like spikes. So, my topic is to cover those abnormalities which look like spikes. When we say interictal discharges, there are a couple of qualities which are important. Usually interictal discharges, especially spike and wave, is biphasic or a bit triphasic. Initial going up, then going down, and those slope are different. There is asymmetry of ascending and descending wave, and then it is followed by a slow wave, and the ongoing background is disturbed. So these are few of the qualities of interictal discharges. But you should know that a single point is not enough. We should know not only these limbs, slow wave, disturbance, also the field. So it should be in different areas, nearby areas involved. So there are a couple of different groups for non-epileptic patterns. We'll go slowly, and we'll cover the most important parts, which is non-epileptiform patterns. It is there in almost 20% of the EEGs when we routinely see EEGs. So, rule of thumb for diagnosis is most of these abnormalities happen in drowsiness or in light sleep. They disappear when some person is in deep sleep or in awake state. Will not disturb the ongoing background activity, may be positive, may be negative, and slow wave will not be seen. And mostly they are in adolescent group. So adolescent age and drowsiness. So this is very crucial combination. So they may be sharp contoured or may come in trains. Sharp contoured ones are BSSS, wicket wave. Wicket wave can also come in trains also. Then comes 14 Hertz, 6 Hertz, phantom spikes, RMTD, SRIDA. So when we talk about BSSS, this is one of the commonest abnormality seen in EEG. It's a benign variant, no need to report it as epileptiform discharge. It is very small, less than 50, very brief, less than 50. So this is one of the rule. Appears in sleep as a single one and more in the frontotemporal region. Maybe unilateral, maybe bilateral, may come on either side anytime. So this is one of the example of BSS. You can see a very sharp activity. The amplitude is very small and duration is very small. Couple of examples. You can see this very tiny activity seen in the left side, and this is nothing but BSS. So the only point is how to differentiate it from a spike. It is looking like it is coming in the frontotemporal region. Why it is not a spike? One is the amplitude, other is the duration. You can see that in a spike there will be clear-cut higher amplitude after coming slow wave, and the duration will be more. So in the referential you can see clearly this BSSS, which comes like a tiny one, and the spike. Next is wicket wave. Wicket wave looks like a Greek word mu. It is again RC form, can come as a single one, but can come in clusters also. It is amplitude wise again of a lower amplitude, but it can come with a frequency of 6 to 10 Hertz, seen in the temporal region. So that is another characteristic, more commonly in the anterior to mid-temporal region. Can be unilateral, can be bilateral, commonly seen in drowsiness. So if you see here, there is a bit of phase reversal here, some sharper activity here. These most of these benign variants are not very well seen in bipolar montage. They are better seen in the referential montage. You can see a sharp activity here occurring in train. So these are wicket waves which may mimic like temporal spikes. So differentiating point, one is amplitude is less, two, it doesn't disturb the ongoing background activity, it will appear only in drowsiness, and the location is fixed, it will be only in the temporal region. You can see another example. It can show phase reversal, because phase reversal does only mean that there is potential which is generated at a particular area. Another example, single wave, drowsiness appearing in the temporal region. You can see before and after there is no disturbance in the background activity. This one is in the trains. You can see almost 6 discharges in the left side temporal region. Another example of. So how to differentiate it from temporal spike? Again, wicket will not disturb the background. There is no aftergoing slow wave. It will disappear in deep sleep, while temporal will be more prominent in deep stage of sleep. So an example of wicket wave versus a spike. You can see that after coming slow wave and disturbance of background activity. Now comes 14 and 6 Hertz positive spikes. So these are also not actinoids. Mostly happen in pediatric age group. Last for less than a second. Again, amplitude is very small. Look like spindle-like morphology, but they are more sharper and they are positive. So these are the two important points. Mostly seen in the posterior region. So while the spindles are seen in the anterior region, the 14 and 6 Hertz are in the posterior region. Can be unilateral, can be bilateral. So in this case, these are looking like spindles, but if you see carefully, they are very sharp and they are looking down in the referential, indicating they are positive. And the frequency will be fixed 14 Hertz in case of 14 and 6 Hertz in case of 6. So in this, again, they may not last for 1 second. They may be appearing only for half a second. In half second, if there are 7 activity, that indicate 14 Hertz. This one is of 6 Hertz. You can see from here to here, 1 second is roughly 6 Hertz. And then again in referential, they are looking down. They are sharp like a comb-like appearance. So this is ctenoid. So differentiating it from spindle is waveform will be more archiform, more spike sharper. Amplitude is low, more posterior. Here it is anterior. So one example, you can see this sleeve spindles appearing anteriorly, while the 14 Hertz is appearing posteriorly. Another 6 word is used for 6 Hertz spike and wave discharges or phantom spikes. They will only be of 6 Hertz frequency. Here the differentiating from spike, true spike and wave is that the spike will be very, very small and slow will be very prominent. So they can be anterior dominant or posterior dominant. Anterior dominant is seen in male, known as VAM, and posterior dominant is seen as in female, known as fold. So one example of anterior dominant 6 Hertz activity, wake, high amplitude, anterior male. Another example, you see this beautiful 6 Hertz activity with a very tiny spike and a high slow wave. Posterior dominant one, smaller amplitude in the posterior region, known as fold. Next is RMTD or RTTD. This is rhythmic theta activity seen in temporal region, again in drowsiness. Because it runs for a quite longer period, it may mimic like a seizure. The only differentiating point one is that it doesn't vary. From onset to offset, the frequency remains same, amplitude remains same, distribution remains same. And usually more rounded one, at times it may be sharply contoured. Maximum seen in mid-temporal region. Can be unilateral, can be bilateral. So this is a bit sharply contoured, seen in the left side temporal region. In the referential, it is better seen. You can see this theta range, rhythmic activity, practically no change in the frequency or amplitude. So differentiator is from seizure. It will be sharply contoured, abrupt onset without any evolution. Then comes posterior slow wave fugue, which also can look like a slow wave. If it is preceded by a sharp alpha, it may look like a spike and wave discharge. So you see this sharper alpha followed by a slow wave. So this can mimic like a spike and wave morphology, especially in adolescent age group, teenage. So in teenage, anything coming slow in occipital leads, take it like posterior slow wave fugue until less proved. Then some other variants like hyperventilation induced slow waves. Many a time these slow waves are reported as generalized spike and wave discharges. Any slowing during hyperventilation which is generalized of any high amplitude is normal until unless proved otherwise. Hyperventilation 3 Hz spike and wave will be totally different. They will clearly show a dot and dome appearance. Here you don't need to look for any spike. You don't need to search for the spike. Any delta wave just during hyperventilation is likely to be a normal variant. Another example. Then comes hypnagogic hypersynchrony, which may also look like this hyperventilation slowing. So it happens like a sudden burst of slow wave, lasts for 1 or 2 seconds. Again, it is more in adolescent age group. Like this sudden burst during drowsiness can happen. Drowsy burst, which is nothing but a normal variant. This is also reported as spike and wave, so avoid these kind of mistakes. Similar thing can happen in hypnopompic during arousal. At times, arousal may show arousal response where there can be kind of an evolution. You feel that there is a change going on. The patient was sleeping and then suddenly some theta activity is coming in the frontal region and then they start some rhythmic delta. So this rhythmic evolution of theta delta during arousal response is absolutely a normal response. This is not an electrographic seizure. At times, even sharp vertex waves may look like spike and wave. So any sharper activity in the central lead C3, C4, CZ should be taken as vertex wave until as proved otherwise, especially during sleep. So another example, very sharp activity with phase reversal. It can be unilateral, especially in pediatric age group. Unilateral vertex wave is quite common. Last is post, which has been covered, but I'll just show that to clear the confusion between post and occipital spike. Post will be positive. The name is positive occipital sharp transient. So to look for whether it is positive or not, look in the referential montage. In referential, it will go down. So that is post. Another example, in bipolar, if it is going down, then this is occipital spike. So here it is bipolar, P3O1, it is going down means this is occipital spike. In the referential, so occipital spike will go up. In the referential, occipital spike is up while the post is down. So this is how to differentiate. So to conclude, benign variants are very common. If you are not able to recognize properly, you can report it as epileptiform discharges, and that can unnecessarily lead to wrong treatment. So be careful while reporting these abnormalities. Thank you. So now we'll again go to the discussion part, and again please go to your rooms as before. The faculty will rotate. We'll do lunch after the discussion. So our target is that by 2:15 we should finish, maximum 2:20, and then we'll take lunch. So please go back to your respective halls.